Now, we've talked about this a lot, but there's a little blurb at the top here. What's the point of sketching? In sketching, I think we've said this before too, yeah, because polynomials, we do sketching. It's different from accurate graphing, right? Accurate graphing that you do in grade 9 and 10 with straight lines and parabolas is sort of teaching us about transformations and that kind of thing. But sketching is different. Sketching is, where it's not on a grid, it's just on a piece of paper. We label important properties that we can find, and it gives us a general idea of the behavior of the function, of some of the important properties of it, and what it's like in sort of various aspects of the function. And a great example of this is how we used polynomials by sketching them to solve inequalities. Our graph did not need to be accurate. If it crossed and it turned, I didn't need to know where that turning point was. I just need to know where the X-intercepts are and if it's above or below at any time. So end behavior, degree, and sign of the coefficient, and X-intercepts is all we needed. We didn't need any other properties, right? So that's the value of sketching, is it gives us a general idea of what the function looks like. And to some extent, it also allows us to understand some different algebraic things, how they impact the graph. Like multiplying by 2 or something would be a simple example of that. Or dividing by a polynomial. How does that impact the graph? That's what we're kind of looking at in this whole unit. And for us, because this is all we know how to find, when we sketch rational functions, we're going to do it with the following 3 things, which are intercepts, y-intercept always, and x-intercepts, the asymptotes, and then what we're adding is the behavior around the asymptotes. So those are the 3 necessary criteria, because those are the only things that we can do. Those are the only things we have skills for. But for those of you taking calculus next semester, you'll gain a new skill and you'll be able to find new properties, and you do all this sketching again, but adding a couple of extra little properties to your graphs, because you've gained a skill to be able to do that. Okay? So we are graphing with the skills we have, and our graphs are going to look pretty good. Now, you already saw this and the learning goal we just took up and the stuff that we did a couple days ago is in our brains, we're already building patterns about what these graphs look like. And for somebody who didn't do the homework or any of the practice, they would really be losing out on how much of a variation these graphs can have. So a big part of what you're getting over the next 3 or 4 days and over the weekend as you practice, hopefully, and even if you don't practice, you can take the work and punch the functions into GeoGebra online and just look at the graph to see what it looks like. Oh, I never knew they could do that. That kind of thing, okay? I'm going to really quickly show you some different ideas of how the graphs can look, and it'll give you a sense of how different these things can be. So look at this one. All the ones that we've seen so far, when one of the sides of the graphs did this, the other side did this. But that does not always happen. Look what happens here. The function approaches that vertical asymptote from both sides going up. That can happen. Okay? It's not always one side's up and one side's down. And look at this. It doesn't approach from above. It actually crosses the horizontal asymptote, which is possible. You can never cross a vertical asymptote. That's a rule you can put in your mind, but you can cross horizontals. It crosses below, turns, and approaches from below. So when you're doing the testing, this is what you're looking for. What is the behavior around the asymptote? So that you know if it approaches from above or if it crosses and approaches from below. What about this one? This one's similar. It's just both are going down and both are approaching from below, so they can look like this as well, similar to the other one, but it doesn't ever cross and approach from the other direction. This one that's what an oblique asymptote looks like, so stay tuned for tomorrow, but that's what they look like, and they can have a little bit of variation on that as well. And then take a look at this one. So this one's got that side and that side, which looks familiar. But then it's got this squiggle in the middle as well. And sometimes that squiggle in the middle might look like this instead, or something like that. So again, there's no trick to figuring it out. You've got to test every asymptote on both sides to see what the behavior is. That makes sense? All right, let's get into this and do one. When you do this on a quiz or a test or in your notes, like in the homework, you will notice it says, sketch the following functions showing the criteria that we just discussed, those three things: intercepts, asymptotes, and behavior around the asymptotes. So this question doesn't say that, but that's what we're going to do. And I think I might have mentioned this yesterday. It's a good idea to build some habits around this because it'll speed things up. These things can take 20 to 30 minutes to get through an entire sketch. So anything you can do to speed up the process would be helpful. And just like the order that you do things so you're not humming and hawing about where to start could be one of them. So first thing I'm going to do is factor the top, factor the bottom. Top doesn't actually factor in this case. And the bottom does factor. I'm going to do some of this quickly. We're going to maybe punch one or two values into our calculator, but I'm going to just come up with them to save some time because I want to get through two sketches. But if you don't understand where a number comes from, ask, because I don't mind if we don't get all the way done. Okay, so ask, don't get lost. But some of this is from what we did yesterday and that kind of thing, and it does take a long time, and I want to get through a couple of them. Okay, so I usually like to come up with both forms, the fully simplified form and the fully factored form first. Okay, but if you didn't do it, then you would just factor it as needed later, kind of thing. Okay, and then we're going to do intercepts. And I'm going to start with the y-intercept. How do we find the y-intercept? Thank you. So which one do you want to sub into? Probably standard form, but I don't know. Because all the x parts go away and you get -3 over -4, which is 3 over 4. And we usually like these things. We always like these things, I should say, as decimals. 3 over 4 is an easy one, but we like to write them out as decimals. And what about x-intercepts? Oh, so I'm going to make a little note to myself. When x equals 0. What about x-intercepts? Thank you, very nice. So there's two ways you could think about this. Technically, it's when y equals 0. But in this case, when does y equal 0? When the numerator equals 0. And so for this one, sometimes it's obvious and easy. This one's a little bit strange. So I'm actually going to set it to 0 and solve it. And we want these as decimals, so I'm going to get my calculator out, and I'm going to find out what this decimal value is, and it's 1.22. And imagine somebody forgot to take the plus minus of the square root when they went to sketch and they thought they only had one x-intercept. They would be totally confused. One of the great things about this, and you'll see it in action when we start sketching, is how all the properties match. So the end behavior and the asymptotes, if you've done it correctly, will match with the intercepts. And you'll like see it happen. You'll be like, okay, that all makes sense. And if something ever doesn't make sense, and you're like, why is that x-intercept there? Then you've done something wrong, right? If you're having a hard time getting it to go through the x-intercept, or we saw this in polynomials, if you've got extra x-intercepts, you've done something wrong. Okay, so plus minus, we have two x-intercepts in this case. And that's it. That part's done. So what's next? Asymptotes. Now we've already factored So where do the asymptotes occur?
4 over 3 and 1.
How'd you get those?
When the x is on the denominator, r equals 0.
Very good. So when the denominator is 0 is when we have vertical asymptotes, which we're going to do vertical asymptotes first. So the vertical asymptotes are x equals -1 and x equals 4 over 3. And this is when the denominator equals 0. And again, I really like, this is just me. Not everybody's like this. But it's a recommendation that I think it would make your life easier, where you kind of always work left to right. Because we're going to have a lot of information to put together at the end. And if you do it in this, doesn't matter what order, but the same order every time, and then you go to look for it in that order, it'll just speed things up and you won't have to think about it quite as much and that sort of thing. So I'm going to start with the asymptote that's furthest to the left, because we have to now do testing around the asymptotes. How do I test around a vertical asymptote? I'm doing a sketch, but I'm going to erase it, so it's going to get in the way. I don't think you should do a sketch here. Imagine I have this asymptote at -1. What values am I going to test, and what am I going to, this is what we did yesterday, what am I going to look for as the output of those values to test the behavior around this asymptote? What might be happening around this asymptote?
You could choose -0.99 for the right side.
Yeah.
And then -1.01 for the
And what do you think is going, what are we going to get? What's going to happen? Yeah.
Well, on the left side, I was going to use 0.2.
Have you already done it? You know that already? Oh, it might, or it might go up, or it might go down. So we're going to get numbers that show that y is going up, or numbers that show that y is going down. Remember, functions are set up such that you pick the x always and solve for y. So in this case, we care about y, but we can only pick x. So we're picking x's. And picking an x very close to the asymptote, but just to the left of the asymptote, will tell me if the graph is going up like that or down like that. And what's interesting here, so I'm going to do some of this for us. But what I'm going to do in my calculator is I'm going to program it 2a squared. So I've got a bracket 2a squared minus 3 bracket divided by bracket 3a squared minus a minus 4. Okay, so you said check, just watch for a minute, don't write anything down. F at -1.01. So I go -1.01, store that in A, recalculate, and I got -13. I don't know that that's big enough. A graph could go to -13 and turn around and go the other direction. It's probably safe. But what I'm going to do is, and this is a big part again of what you're doing, it's finicky, it's messy, it's a bit tedious, is getting used to the idea of what are big enough numbers that convince you what's happening here. So I'm going to try -1.001, and because I've put it in my calculator, it's really easy for me to check them. And now I got -142. So what's this graph doing? It's doing this, right? I mean, 2 values is even nicer. And I could do 2 values quickly because I can see one is low and the other is lower as I get closer. But it's a lot of extra work to do 2 values all the time. Okay, and then the other value you said was -0.99, but I'm going to add another 9 to that. -0.999. Watch what if I put positive 0.999 in. I got 0.5. And I'm like, what? What happened? Oh, right, it's got to be negative. If you do it wrong, you'll probably get strange answers, and hopefully that means you'll find the right answer. So this one is 143. So from the other side, it's going up like that. So this one means, and we're going to write this down, as x approaches -1 from the left, y is going to -infinity. As x approaches -1 from the right, y is going to +infinity. But we have two asymptotes, so we have to do the same thing again for our other one. What is 4/3 as a decimal? See, now this is tricky, and we're doing this for a reason. It's all well and good to when you got integers, but all of a sudden we've got fraction that's a decimal value, and things get messy.
1.33. ...
So what is just to the left of that?
Stick 4 at the end.
That would be which direction? That's going to be bigger or smaller?
Right,
That would be to the right by ending with a 4 instead of a 3. Good. What would be just to the left? A 2, but we can do even better. Say again? 1.3, but we probably want a few more decimals, so I think 1.333. Like if I truncate, that's below, right? And I want to show you something, because I was playing with this earlier. 1.332, if I punch that in, I get -58. That's pretty good. 1.333, if I punch that in, I get -237. That's the difference that it makes. Crazy. You know, if you, like, so they were both negative, so I know we're going down. -58 is probably good enough. We're not going to have graphs that go like that, I don't think. But I mean, that's up to you. You gotta work with this stuff and get to a point where you convince yourself. Don't ask me on the test, is this big enough? Does this, no, what? Okay, so this tells us as x approaches 4/3 from the left, y is going to -infinity, right? It's going down. And then I like that idea, 1.334. And that gives us 119, 120. So positive. Any questions about that? Okay, so that is the asymptote testing for the vertical asymptotes. The last thing we need is the horizontal asymptotes, and then we're ready to sketch. And we haven't even done the horizontal asymptote yet. What is the horizontal asymptote? A couple people think they know. Anybody else? Isaac? 2/3. So these are both degree 2. Remember, if you have a bigger degree on top, that's oblique asymptote. Bigger degree on bottom, your horizontal asymptote is y = 0. But the same degree means I look at the highest degree term, and I just look at those coefficients. So 2/3. So the testing for this is very different, and every year there's a few people who get them mixed up or get them confused or don't fully understand. So all I can say is you got to understand what you're doing, why you're doing it, why we do one thing for vertical asymptotes and something very different for horizontal asymptotes. When I have a horizontal asymptote, where does the function begin to approach that asymptote? For the vertical ones, it's when your x is close to that value. What does x look like when we get close to the horizontal asymptote. Really big. Big numbers, negative or positive. Very good. So we got to make sure because we can't pick y's. I can't pick a y value close to that. So we're going to pick big values that are negative. And again, I'm always going to work left to right. And so I got 0.6664. And for positive 1,000, I got 0.6669. And what is 2 over 3? 6666. So this one is where? Just below, very good. And this one is above. So I'm going to write that down. Below, above, but we're going to do it the nice way as well, which is as x goes to negative infinity, y is approaching 2 over 3 from below. As x goes to positive infinity, y approaches 2 over 3 from above. But you want to, like, you need to know how to say it the proper way, but really in your mind you're thinking below and above. You got to know that that's what that statement means. Is everybody, any questions? We've done all the work. Now we're going to put it together to make our sketch, if you can believe it. All right, let's do it. Before you draw your axes, you might kind of think to yourself, where approximately are all of the details? I've got a vertical asymptote on the left and one on the right. Like I've got a negative one and a positive one, and I've got an x-intercept that's negative and an x-intercept that's positive. So I've got some numbers on both sides. So I'm just going to kind of do a cross and like in the middle, like centered like that. I'm also going to look before I start putting anything in. 4 over 3 is just a bit more than 1. And I have negative 1. And my intercepts are both just a bit more than 1 and negative 1. And my y-intercept is just a bit less than 1. So everything's like centered around 1. So my scale is going to be just like, 1 will kind of be there, I guess. Does that make sense? And I think the best thing you can probably do is graph your asymptotes and your intercepts. Put them on first. Make sure they're on the right sides of each other. Okay, that's what we're going to do first. So I have a vertical asymptote, and we're going to label them at y equals negative 1. And I've got one at, is that over far enough? Y equals 4 over 3. And my horizontal asymptote is a bit less than 1. And my x-intercepts are negative 1.2 and positive 1.2. And my y-intercept is 0.75, which is a little bit more than 2 over 3. Oh, yeah, sorry, my goodness. I've mislabeled my vertical asymptotes. Is that what you're saying? Yeah. Thank you. So this is 3 over 4. Yikes. But everything else looks okay relative to everything else. This is negative 1.2 should be to the left. That 1.2 should also be to the left. 3 over 4 should be above. If you got any of those things out of whack, things would be strange. Some of them you might get away with, but a lot of them would be strange. Now again, the order that you do this can be whatever makes the most sense to you. I'm going to go asymptote by asymptote. But you could do like the left section of the graph, then the middle section of the graph, then the right section of the graph. Maybe you'd prefer to do that. I don't know. And this is how I'm going to do it. Rereading the statement. As I'm approaching from the left, and because I did things in the same order, I kind of know the order that they happen, right? So as I approach from the left, I'm going down. What does that tell me? Going down. I'm going to erase that later. You might just pencil it in lightly. You know what I mean? And then you can draw over it. Because it's going to depend a little bit on exactly where things lie. But I know that I'm going down like that. Okay, so this one's going down. And then, as x approaches -1 from the right, I'm going up. So this one's going up, like that. Okay, next asymptote. As I approach 4/3 from the left, I'm going down. As I approach 4/3 from the right, I'm going up. Remember when we saw those graphs before, it doesn't always flip-flop like that. You have to do the testing and understand what it's telling you. Now I'm going to stop here because take a look at the middle of the graph. Take a look at how much sense it makes. Can anybody tell me what I mean by that?
It makes sense. It looks like there's like a twist, like a cube twist kind of dealio.
Uh-huh.
And we're going to have to cross the horizontal asymptote.
Yeah, and like, why do you think that?
Because the y-intercept is above.
Yes, and the x-intercept is below, and like, it all kind of makes sense. So if I get rid of these, and I'm going to go like this, I'm going to come in from here, go down like that. And we saw a graph that looked kind of like that, right? My asymptotes might be a little out of whack. It's a little bit hard to get through there, but. Okay, now we got to include our horizontal behavior. And this one is, as I'm going out to the left, I'm approaching from below. So this one's going to go like this. And then the other one says, as I'm going out to the right, I'm approaching from above. So this one's going to go like this. And again, look at this makes sense because I've got an X-intercept there. And just check that everything's labeled. I've labeled my asymptotes. I've labeled my intercepts. Any questions? Yeah.
How can I know the curve on the very right? How can I know it's curve?
Here? Well, it approaches as it approaches from the right, it's going up, and as it's going that way, like our testing told us that, right? And as I'm going out to the right, it's approaching from above. This is what this says right here. So I don't have any values in here to know exactly what's happening, but that's fine. And it's like, if you're wondering, well, how do you know it doesn't do this? Well, they never do that. So that would be some other kind of, like, it would require more complexity in the function to do that. So if there's nothing telling me that it's like crossing the x-axis, so there's intercepts there or something like that, then it's just a smooth curve.
And then, so there's no testing that like tell us that it goes through the y equals 2 over 3 window? Like, do we just assume that because of the other two testings?
Yeah. You mean this? Do you mean there?
Yeah.
It has to, because it's up there and it's down there. Yeah, there's no way of checking to see, but it has to, right? It has to. Yeah.
For the horizontal asymptote, why did you use negative 1,000 and positive 1,000?
Because it's going to go this direction for one and go that direction for the other. Folks, take a look. It'll never do this. Somebody tell me why. It'll never be both going that way. Why? Thank you. That's not a function. All of this is functions, and you can't have y values over top of other y values. So one will always be going this way, and the other will always be going that way. Could they both be from below? Sure. Could one be from above that way and one be from below that way? Yes, absolutely. But that's a testing we're doing, and there's only two. You're only ever going to have one horizontal asymptote.
So every time we're doing the horizontal asymptote, we're going to just use negative and positive 1,000?
That's what I would do. Yeah. All right, let's do one more. This one's going to go even faster. There's a couple of important details that I want to get to in it, but we're going to kind of whip through a few parts. So bear with me. Intercepts, asymptotes, behavior. Those are the three things that you have to do. And I like getting my forms right first. In fact, it's a really good idea to get your forms right, because if you have a hole somewhere, you probably want to find that first. The y-intercept is when x equals 0. So 0 plus 2 over 0 squared plus 7 times 0 plus 12. So 2 over 12, which is 1 over 6, which is about 1.17. And the x-intercept, -2. Realize that last time we had to do a little solving because it was like 2x minus 3. It was kind of nasty business on top. But in this case, it's easier because it's factored on top. 0.17. Oh my gosh, yeah. That would have been a problem if we tried to graph that. Thank you. Asymptotes. What are my asymptotes? Isaac? -3 and -4, they came from when the denominator is 0. Again, it's factored, so it's easy to spot. So, and these are my vertical asymptotes. And again, you notice that, whoops, we're always doing them in the same order, and that does, I believe, make your life a little bit easier. Now we got to test them both. Every test requires two values. So I'm testing x equals -4 first. What are some good values to test around -4? Yeah, and? Yeah, good. So, and I'm going to start with the one on the left, -4.001 and -3.999. Now write that down and then stop for a minute. And I want to show you a trick that will save some of you time. But you can just punch this in, and we're going to do that as well and get the values. take a look at this factored form. When I put that into there, what's it going to be, negative or positive? Negative. When I put that into there, what's it going to be, negative or positive? When I put that into there, what's it going to be, negative or positive? 3 negatives makes a? Now, I spent a long time thinking about how big it's going to be, but in this case, it really doesn't matter. Because no matter what you do, it's going to be negative. I can add as many zeros to that as I want. That's going to be negative because I'm going to get 3 negatives. There's no way to change that. Do you see what I'm saying here? So sometimes you don't even have to get your calculator out just for these ones. Horizontal asymptotes, you have to. If you don't like that, use a calculator. What about this one, negative 3.999? What the top is going to be? This is going to be, but that's going to be positive, no matter what you do. So 2 negatives makes a positive. So I already know by inspection, let me see if I can get this one right. This one's going to be negative, and this one's going to be positive. And sure enough, this one works out to negative 1999, and this one works out to positive 2001. So as x approaches negative 4 from the left, y is going to negative infinity. And as x approaches negative 4 from the right, y goes to positive infinity. You could just write negative or positive in that case. Yes, that's fine with me. So for this one, just to the left is going to be negative 3.001. Just to the right is going to be negative 2.999. And you can do the same thing, but I get 102 there and negative 998 there. You could do the same thing by inspection for this. When you have those nice factored forms, that will usually work. So this one's positive and this one's negative. And this one is as x approaches negative 3 from the left, y is going to positive infinity. And as x approaches negative 3 from the right, y is going to negative infinity. Okay, last thing, horizontal asymptotes. What is my horizontal asymptote? 0. Why? Yeah, because the degree on top is smaller. The degree on bottom is bigger. So it's y equals 0, which usually kind of makes our life easier, to tell you the truth. So this is where we use negative 1,000 and positive 1,000 every time, as we just discussed. And when I punch these in, I get negative 0.001, and I get 0.0009. I don't know why I have so many decimals here, but 995. So what does this mean? Where am I for the first one? It's below 0 because it's negative and it's very close to 0. Where am I for the second one? I'm above 0 because it's a little bit bigger. One of the mistakes people make is they do positive and negative for this one, right? Because they get used to doing that for the vertical. So they're like, oh, it's positive. But what if I did that for this one? What would be my problem? Oh, it's positive. Huh? Like these values. Like these values here. They're positive. Yeah. Well, what I would say is, of course they're positive. The asymptote's positive. Of course they're going to be positive. For this one, because the asymptote is 0, the fact that it's negative or positive is kind of relevant, but that's for vertical asymptotes that we worry about that. So this is as x goes to negative infinity, y is approaching 0 from below, and as x goes to positive infinity, y approaches 0 from above. Now we're going to put it all together. You got to make sure you understand why. Remember, intercepts, that part is hopefully easy. Finding the asymptotes is probably not too bad. Doing the testing is where more people have trouble. And then we have to know how to put it all together. Something really interesting happens at this one. So we only have 5 minutes, but we're going to do this sketch. Both of my asymptotes are vertical asymptotes are negative, and my X-intercept is negative as well. So I'm going to do my sketch kind of like this. I'm going to put in my asymptotes. Okay, and start with the behavior. As we approach -4 from the left, we're going down. As we approach -4 from the right, we're going up. Next one. As I approach -3 from the left, I'm going up. As I approach -3 from the right, I'm going down. It's kind of hard to see, especially if you're like paper on or pencil on pencil, but we've got our horizontal asymptote there. And so that's the last one that we have to do. As I go out to the left, I'm approaching from below. So now I kind of know what this one looks like. I'm approaching like this, right? So this one's going to come up and just go out like that. And I kind of know what's happening in the middle here too, so we might as well do that. How do I know that it turns and goes back up like that? How do I know that it doesn't do it down here? Thank you very much. There would be X-intercepts calculated if it crossed the X-axis. Do we know what point that is? Is it really low? Is it really high? You could check 3.5. It's not necessarily in the middle if you wanted to, but you don't have to. But that's what we learned in calculus. One of the things we learned in calculus is how to find that point. So that's good enough for that one. And then, the last one is, as we go out to the right side of the graph, we're approaching from above. So somebody tell me something about what's happening here. Remember, this one's down here. So I'm and I've got an intercept, so I know it's crossing as well, right? And I forgot my y-intercept. My y-intercept is 0.17. So I'm going up and I'm turning. And I'm approaching from above. And that's how you can know that that's happening. Yes? Because I've drawn enough of these that I just know. But how would it not? Could you draw it so that it doesn't? Like, just watch. If the x-intercept was here and the y-intercept was here, I probably would have done that. You know what I mean? But trying to do it like this would be like that. I don't know. It just felt natural to me. You're not going to get nailed on that stuff, but you should be starting to develop a sense of what these things look like.